another Canadian city.
Ooh, change it up a little bit. What do you think? Anybody who's in the chat, tell us what city we should do. What do you think?
Well, it's kind of a trick question, right? Because the sky is different. The sky is the same, but roughly the same latitude.
Yeah, that's a good point.
So
Canada is basically Chile, like this in terms of population. It's like turning Chile on its side. We're all in one big line.
that's right.
Hello, everybody. Oh man, we've got a whole bunch of people from all over the place here. Oh, we have suggestions of Yellowknife and Whitehorse there because they're further north. Ooh, ooh. For those, and we've got Victoria, Snow Lake, Manitoba. For those who are joining on YouTube right now, we're just trying to decide if we should change the location in Stellarium from something other than Toronto, aka the center of the universe, to somewhere else.
Don't say that.
Yeah, I know, everyone will hate us then. I really like the idea of Whitehorse because it's so far north, but if that's going to throw off your constellations for today, then maybe we should stick with something.
Yeah, all but one question. There's one question where we should probably stick to southern Canada, but actually, I think I'll do a cool demo to do with that.
Okay.
So let's start off by sort of jumping off that topic, and what we can do.
Can I just quickly announce the topic?
Yes, want to do your intro?
Yeah, I'll just say, because we are just 1 minute over 3:30. Hi, everybody, and welcome. Oh, took a good recommendation. Regardless, welcome to our session today on the website. I know there's a bunch of folks joining from, I believe, Kootenay. So hello to everybody who's out in BC. And I just wanted to let you guys know that on our website, we had advertised that we were going to talk about the planets today, but we have spoken about the planets a lot already, and there has been a ton of interest in constellations and stars. So we're going to answer the questions from mission 2 of the scavenger hunt, and we're going to talk about the stars, and we'll talk about planets as a dedicated topic a little bit later in the season. If you guys, as usual, if you guys have any questions as we go along, please ask them in the chat, or you can ask them in the Q&A, and I will sort through and interrupt Chris whenever I feel like it, if that's okay with you.
That's right.
All right, Chris.
Good. All right, so here's a fun game we can play. So considering we have viewers from all over, so what we'll do is we'll switch over to north. Our time, our TARDIS, Doctor Who TARDIS controls. So I hope there's not a copyright violation doing that. And we'll just set the sky to tonight. Let's
just a heads up, Chris.
Yeah.
You're not sharing your screen yet. So if you're intending for us to see this,
I am intending you to see it. Let's go there. All right. So what I've done is I just swung Stellarium around, faced us north, and I just set the time to tonight at 10 p.m. at exactly 10 p.m. And of course, we talked about Polaris the other day. Polaris is an important star, not because it's bright, because it is. It's about number 44th in brightness in the sky, but it's famous and well known because it's important. And it's important because it's close to the point that the Earth's axis of rotation aims at in the sky. And on Tuesday, I talked about the fact that the moon rotates on its axis once every month, and it has its own different pole star. And each planet in the solar system will have its own pole star. So you use Stellarium to travel to the different planets, throw up your equatorial grid, which is down here. Oh, there we go.
Chris, just a heads up.
Equatorial grid is this one. And then it'll put a bullseye, or it'll be concentric at the pole star of the planet you're sitting on. And then you can zoom in and see which prominent star is closest to that. So there's Polaris, we've got that in view. Now, the fun part is, let's start traveling through Canada. So right now we're sitting here in Calgary. If we went back to Toronto, we could see whether the height of Polaris varies above the horizon. So let's go back to Toronto. Let's do like that. Let's just go back to the default. There's Toronto. So if you look at this list of material here, you can see all these little items of information. I'll actually break this down in a section and simplify this for everybody.
Sorry, Chris,
Go
I
ahead.
don't want to interrupt, but your microphone's breaking up a little bit.
Let me plug in my wired mic and see if that helps.
While Chris is getting set up, Chris has worn a space-themed shirt every single session, and I finally caught up, and now I'm wearing one referencing the Pioneer satellite. So, or not satellite, the Pioneer probe. So I'm feeling pretty proud of myself today.
Got to represent, but do you have space socks on like I do?
No.
Okay.
Someday I'll make it to your level.
There's still time. How's the audio?
Audio is good. I'll let you know if it breaks out again.
Okay. So if you look down this list of information about, so when I point at an object and select it by clicking on it, it's starting to see information about the object. And when I've selected Polaris, so you get the name at the top. And if you look down this list, at one point, the one line says as./alt. That's your azimuth or your directional compass in degrees. And that's your altitude in degrees, plus being above the horizon, negative would be below the horizon. You can see that the height or the altitude of Polaris above the horizon for Toronto was 43 degrees. Now, if I go back to Calgary, the altitude is gone to plus 50 degrees. So it's gone higher. It's gone higher in the sky. And what's happening here is that the height of Polaris above the northern horizon is equal to your latitude on the Earth. We also learned the other day about measuring angles, and I could turn on the angle measurement and I could drop a vector down to the horizon and measure that roughly 50 degrees above the horizon. I'm
Very
just gonna
cool.
turn that back off. All right, so what other more northerly viewers do we have? We had somebody mention Yellowknife. Let's go there. All right, has we gone to Yellowknife? Let me just reset this and go to Yellowknife.
There it is.
Yellowknife, Canada.
Oh, here we go.
Polaris has hopped up even higher. Now it's sitting at 62 degrees. And do we have anybody even farther north?
We had a visitor, or in Ottawa Center's meeting, they had somebody from Iqaluit. Could you check Iqaluit?
Let's see if Iqaluit's in here. Is it
IQA.
IQA.
Nope.
No.
Okay.
Well, what we can do is we can cheat. We can just take our cursor, put it on the degrees north, and we could start driving north. You can also see that the sun is getting brighter, the daylight's getting brighter. And that's because we're getting into the time of the year as we're we're now into spring, where we get into 6 months of daylight at the north, near the North Pole. And so at high northerly latitudes, we're not quite at that 6 month, but we're getting close. So now they're getting long lengths of twilight time in the far north. So we can head up here. We're at 71 degrees. We could head up into the Aleutian Islands, and we can see that Polaris is now way up at 79 degrees. And of course, if we went to 90, then now Polaris is at the zenith.
There you go.
And while we're at it, if we want to take our north and start driving, if we had a magic car like the Back to the Future DeLorean that didn't need roads and it could just drive, we could just start driving south.
You're outdoing yourself with references this time.
Hey, here we are at 17 degrees north. We're sort of at the Baja California latitude, and we keep going down, down, down. And when we get to 3, 2, 1, 0, we're at the equator, the Polaris disappears on the horizon. So astrophotographers that want to do polar alignments using Polaris have a hard time of it once they get close to the equator, to southerly latitudes.
You won't be able to see it anymore.
That's right. So you have to have different tricks.
So there's a couple questions coming up in the
Yep.
chat that I just wanted to address. First of all, Scott Thompson asked a question about Markarian's chain, but we're going to get to the answers from the quiz in a second. And then someone asked about maybe at some point talking about how the right ascension system works. That might be a topic for a later session. What do you think?
Yeah, I mean, I'll touch on it very briefly, but I think it's better if we approach it in a systematic, understandable way with a bit more breathing space. So,
Okay.
but I can certainly mention it. So what I want to do here is this list of information is very intimidating, I think, to people who might want to use Stellarium and see all this information pop up. So what I recommend is if you go down to your settings window, configuration, and you go to your information box, then you've got 4 options here. All available, short, none at all, and customized. And what you can do is you can sit here and you can add the lines that you want to see. So you can have your right ascension and declination. I'm just going to put a few more. There's my altitude and azimuth. I'll put my ecliptic coordinates. And then I'm going to put my magnitude, my brightness, the type, the size, its distance, what constellation, when it rises and sets, things like that. So I've just got a basic set of information. So now when I point at an object like Polaris, it tells me that its altitude azimuth, as we talked about, gives me its right ascension and declination, which are those coordinates that astronomers use to make their maps of the sky. And then it will also tell me things like the fact that it's circumpolar, that it never sets at my latitude. If it was a star that set, if I were to pick, say, Deneb down here, you can see that it tells me that it rises at 2 a.m., 2:21 a.m. Transits means that it's at its highest point over the southern horizon at 8:46, 8 hours 46 minutes, 8:46 a.m., and then it sets at 20 hours 11 minutes. And it doesn't mean that it could be setting in the daylight, right? This has nothing to do with the sun. So a star can be up in the daytime, so it could be rising and setting during daytime hours. It doesn't matter as far as astronomers are concerned. And you can see down here that it's actually sitting at 1,411 light years from Earth or from the solar system. So that's how you read this little list of information. And if you find that this shorter list is a little bit more palatable or manageable, then just head into your settings and main and save. And that'll be the way it comes up every time you pick something. All right, so let's get into answering our questions and then we'll.
So there are lots of questions in the comments in the Q&A and such about things that Chris could go over from the other times. Just to let you know, all of the videos are up on YouTube. So if there's any questions you have about things that have happened in the past, they're all available up there. And I'll send the link to the last YouTube video out. Oh, I just sent it out with a timestamp. Sorry, I'll get a better one. And
Remind everybody is that this video will be available later, so that okay.
for sure.
So to get back to where we are, let's reset that location. So if you want to feed me the questions, Jenna, we can go through those.
Sorry, I just realized I was listening to you talk in the old video as it was running. My apologies.
That's okay.
Yes, absolutely.
We'll just edit this out in post.
It'll be fun. It's all about post. Okay, so the first question we have for the second mission is, what types of objects form the Leo triplet?
All right, so what we can do is hope everybody went in here, and I think you could search for it this way. Start typing in Leo triplet, hit enter, and the software will center it into your view. And if you start magnifying, you're going to reveal 3 galaxies. And those galaxies are, because there's 3 of them, it's called a trio. And since it's sitting in the constellation of Leo, let me just wind back so we can all see Leo here. This is Leo the lion. And the brightest star in Leo is Regulus. And if you head down here to the other end, or at its tail, that's Denebula. And you can actually, if you're in a very dark sky and have good strong binoculars, you might pick these up. And certainly if you have a backyard telescope, this isn't too difficult a set of objects to see, but you do need a dark sky to see them well. And so that's certainly not the case the next few nights with the moon so bright. But certainly it'll be up in the sky for quite a few months, so you can get out to the cottage once the weather gets nicer, and respecting your social isolation, of course, but get away from the big city and get to dark skies so you can see the Leo triplet. So these are 3 galaxies. Let me just show them briefly. This galaxy is a spiral galaxy that is sitting edge on towards our solar system. So galaxies can actually be oriented in any angle in space. We can see them face on, in which case they would appear as large disks, or we can see them edge on, in which case they appear more streak-like. And what's nice about the fact that when galaxies are close to edge on, all the light from the stars in those galaxies that is shining towards us, eventually reaching us, is actually concentrated into a smaller area of the sky. So if I take all the starlight from this galaxy and sort of squish it down into a narrow band, then that galaxy has what we call greater surface brightness. So it's a brighter object in your telescope, as opposed to a face-on galaxy where the stars are distributed evenly across a wider area, and it tends overall to be a bit dimmer. So this is a spiral galaxy. We're seeing it almost edge on. The nickname of this one is the hamburger galaxy, because it almost looks like the meat in the middle and the brighter parts on 2 sides of the bun.
It's one of my favorites.
Yeah. At one of our future sessions, I'm actually going to go through and explain to everybody what NGC means, what the Messier M numbers mean, and things like that. So in the astronomy catalogs, this is NGC 3628, but it's commonly known as the hamburger galaxy, otherwise known as, there's some other names for it, King Hamlet's ghost and the vanishing galaxy. And this galaxy, I deliberately made sure that we had our distance information on here. So this is 13.8 megaparsecs, which is the formal distance time scale that professional astronomers use. But folks are more used to thinking about light years. And this galaxy is 45 million light years from Earth. So the light's been traveling for 45 million years. So we have the hamburger galaxy, then we have Messier 65, and it also has its own NGC number. This one is, where's my distance? It doesn't have a distance listed for this one. And then we have Messier 66, and it's a distance of 35 million light years away. These would be kind of in a group, in sort of form a galaxy group. So that's the Leo triplet. And I've sort of given you an idea where they are. If you want to find Leo, find Regulus, find Denebula, and there's a medium bright star between them. This is called Chertan. And that Leo triplet is located about a few finger widths below Chertan. All right.
Perfect.
What's next?
Next, we've got, and also that actually leads us in nicely to when we're talking more about constellations and how we can use them to find our way around the sky. The next question is about Markarian's chain. What is it and why is it so interesting?
Okay, so before I hop over to Markarian's chain, I just want to point out that there's a button in the toolbar of Stellarium which is dim right now. This is the deep sky object button. So I'm going to make sure I enable that, and that will actually put symbols and labels on these deep sky objects. So you want to make sure you've got that turned on. And what I'm going to do is I'm going to wind back here. So this patch of the sky, Leo, Virgo, and there's the bright star Arcturus. And here's the Big Dipper up here just for context. This is, you're looking at the east and southeastern evening sky this time of the year. And this is the realm of the galaxies. So I gave you a little taste of the Leo triplet here underneath Leo, but this area of the sky is filled with galaxies. So I'm going to open my menu here, go to my tab called DSO, Deep Sky Object, and this slider tells Stellarium how many objects to put labels on. So I'm just going to crank this up. We'll see what we get here. And you can see that all of these red ovals and orange ovals, each of these represents one galaxy, all with different distances and magnitudes. Let us just wind back so it gets kind of a good clump. And you can see that this patch of sky between this star, which is named Vindia Matrix, and the nebula, contains what we call the Virgo cluster of galaxies. And Markarian's chain is a group of galaxies kind of lined in a row. Let me just wind the numbers back here so we don't have so much clutter.
So there's quickly, just while you're doing that, there's a question from Jim Fisher. How do you delete markers that you no longer require? And changing those sliders like Chris just did is one of those ways to get rid of them.
Yeah, you can do two things. You can turn them all off, or you can use the sliders to control how many you see.
Perfect, thank you.
Yep, good question. All right, so Markarian's chain is actually a group of galaxies that just happen to be lined up in a kind of a loop or a row. And I'm just going to magnify here a little bit more. I'll just turn off the markers for a second so you can see. If you get a good sized telescope and under a very dark sky, you can look for this group of galaxies that are sort of linked together, and they were just given this nickname by an astronomer named Markarian, who discovered this group of galaxies all lined up. And you can find some of the brighter components of this group would be also Messier objects, the so-called best of deep sky list. So this is the spring sky. In the springtime is the optimum time for astronomers to view galaxies because they get to a point where they get nice and high in the sky, and we can view them through the least amount of Earth's disturbing atmosphere. So that's Markarian's chain. And as I said, it's composed of a whole bunch of galaxies. One of the more unique features of this chain, if you look at it in your telescope, is this pair called the eyes, which actually resemble a pair of bright smudges that look like eyes, close together eyes. And you can see that we've got more edge-on spiral galaxies here. We've got these sort of large amorphous elliptical galaxies. They don't have they're not as structured as the spiral galaxies are. And these may be the result of mergers of smaller, many smaller galaxies that could have been spirals that eventually coalesced under the gravitational mutual attraction and ended up as a sort of a giant ellipse or spherical or elliptical shape. So that's Markarian's chain right across here.
So there was a big, long question from Scott Thompson about this. Stellarium identifies some of the objects as galaxies, some as active galaxies, and some as interactive galaxies. Do you know what the definitions are?
Yeah, so an active galaxy is a galaxy which is emitting radio signals because it has an active black hole in the center of it. So we think now that virtually every galaxy has a black hole in the core, but a black hole will not be emitting much in the way of radio signals unless it's actively eating something or processing matter that's falling into it. Okay. So the black hole that was photographed in the news last year was in the core of Messier 87, which is in the neighborhood. Let's just find M87, which is just below Markarian's chain. So this is the galaxy that's host to that black hole that was imaged by the black hole telescope, the radio image of it. And in a telescope, if you have a very good telescope or you take a very good astrophoto of the object, you can actually see the jet of material being erupted by the active nucleus, the active black hole. So that's an active galaxy. Our Milky Way's galaxy has a black hole in the center. I don't think it's classed as an active galaxy. It does give out radio signals, but not as intensely as some galaxies do. And interacting galaxies are those which are actually pulling on one another and in some process of distorting each other or potentially merging together. So that would be an interacting galaxy.
Perfect. Thank you very much. I'm going to move us on because it is 3:54 and we are only 2 questions in. Whoopsie. So the next question is, what creature does the star cluster NGC 457 look like?
All right, so this is actually a bit of a trick question because there's more than one answer, but NGC 457, So this is an open star cluster. It's sitting in Cassiopeia. Here's the Cassiopeia is sort of dangling upright this time of the year rather than being its M or W shape. And if you find Cassiopeia in the sky and you start at the top, count down one star and then the third star. And if you make basically a 45-degree or a right angle triangle with Rukba and Navi, the object that's sitting at the right angle is this object. And this is called NGC 457. And it's otherwise known as the Owl cluster or the ET cluster. And I think there's a Dragonfly cluster. People have different names for it. And in your backyard telescope, you'll see two brighter stars, which are the eyes. You'll see a few, less bright, but still prominent stars in a row coming down from them, down to the feet. And then you'll see two upswept arms or wing on either side. Let me see if I can tip it over a little bit. See if I can do it this way. Yeah, I can sort of get them upright. Here are the eyes at the top, the feet at the bottom, and then the wings.
Okay.
And this is very easy to see in a backyard telescope. So that's your answer. It's a dragonfly or a ET or.
Perfect. I always think these like, what does it look like things are a little bit of a stretch, but I've thought that very much for the ET cluster. But now that you've pointed out that you have to actually, those are eyes and it's got arms. Okay, it makes a little bit more sense. I can understand.
Okay.
Alrighty, and the next question we have is, on what date will Mars start rising before midnight?
All right.
Oh, that's exciting.
So this is a cool question. So let's face east. So we mentioned last week that the planets are in the morning sky. So I'm just going to advance a few hours until we get Jupiter, Mars, and Saturn sitting in the morning sky. So what you can do to answer this question is you can center up Mars in your view. And then you can just start advancing the date. And as I do that, I've got the rise, transit, and set time here. So I want to watch for when the rise time, you'll see it's descending. Every day I click, 329, 327, 325. And I can just make it a little earlier here, make it darker. Keep going. Now I'm in the twos. This is happening because the Earth is orbiting the sun, and as the perspective of the Earth's view of the sky changes, the whole sky is carried from east to west, and at the same time Mars is booting along in its orbit. So the combination of the two is causing Mars to actually rise earlier every night until eventually, by the time we get to, here's June, now we're into July, and by the time I get to about, there we go. July 22nd, Mars will be rising at midnight.
Perfect.
Okay, we're a
That's
little
exciting.
bit before midnight. So this will vary a little bit depending on your latitude on the Earth. But more or less, by the time we get to the end of July, we'll be starting our season of Mars. And that'll carry on right into October when we get the opposition. So that's the answer to that question.
And we're going to talk about that in a different episode as well. We're going to focus more on Mars.
Yeah.
Perfect. Just a heads up, I do see all the questions that are in the Q&A. I just want to get through our scavenger hunt first before we start delving into the questions. So the next question in the scavenger hunt is, when is the brightest star, Sirius, highest in the sky?
All right, so for that, we need to go into the evening. Let's go back and find Sirius. So as I mentioned at the beginning, a little while ago, I was talking about the rise, the transit, and the set. So the rise is the moment when the object breaches the horizon, appears above the eastern horizon. Set is when it disappears in the west. And transit is when it's effectively noon for that object. So what we call noon is when the sun is transiting, when it's above the southern horizon. So I asked you, when is Sirius above the southern horizon? It's a bit of a trick because it's actually while it was still daytime. So on April 9th, Sirius is transiting at 6:49 p.m.
Huh.
So that'll vary by the date. So if we went back, say, a month, then it wouldn't be transiting until 8:52. So I could go up to almost 2 hours later. So an object will transit when it's opposite the sun, it'll transit around midnight, and it varies. So right now, Sirius has already been moved in a little bit into the western sky after dusk, so it's transiting. It's already transited by the time the sun goes down.
Perfect. I just saw a question in the comments and in the chat, and I am going to distract us briefly because it made me smile. Can you show us Ursa Major? That question is from Maria, and she is 10 years old.
Ursa Major, absolutely. So Ursa Major is what we talked about at the very beginning of the conversation when I had Polaris in the middle here. And what I can do, Ursa Major, you mean? Okay, Ursa Major.
Yes, Ursa Major, not Ursa Minor.
Yeah, Ursa Major is up here. That's the Big Dipper. And if I draw the artwork, you can see the bear sitting upside down in the sky. So if you want to find the Big Dipper, what you want to do is after about 9 o'clock, you want to head outside and look northeast, and you should see the Big Dipper balancing on the tip of its handle.
Perfect. And the Big Dipper
about halfway up the sky.
A Big Dipper is very bright too, so it's easy to see even if you're in a big city. So you should be able to go and check it out up in the northeast. Excellent. Okay, back onto the questions in the in mission 2. Our next question is, what constellation will you find the main belt asteroid Vesta in right now?
So Vesta, we could plot in Vesta. Now, when you type in Vesta in Stellarium, you'll see that there are numbers in brackets ahead of the asteroid name. And that's because asteroids all have numerical designations that are basically related to when they were discovered. So Vesta is a large one among the brightest and largest of the asteroids in the main belt. And it was discovered basically 4th. So that's why officially its designation is 4 Vesta. So I'm just going to center Vesta and zoom in. And this is the sky tonight. And Vesta is sitting right between Venus and Aldebaran. Here's the Pleiades. So if you want to go up on the next clear night, if it's clear tonight, you can head outside, find yourself Venus, see if you can spot the bright star Aldebaran off to Venus's south or left. And then you'll know that Vesta is sitting here just outside the triangular face of Taurus. And if you want to just sort of estimate, you can measure off, Vesta is going to be 6.5 degrees. That's about a palm's width. So if you stretch your palm out and close one eye, that's about 6 degrees. Or from this star, it's about 4. That's about 4 finger widths of sky. So there's Vesta.
Perfect. Thank you. Sorry, I'm answering a question and typing out all the answers right now. The next question on the scavenger hunt is at 9 p.m. How many of the Zodiac constellations are fully or partly above the horizon?
Okay. And just before I leave Vesta, I just want to make sure everybody realizes that asteroids move across the sky. So if I step tonight, tomorrow, the next night, the next night, the next night, it moves along a little bit.
Fast.
So yeah, it's quite fast. So if you look for this star called Ain, which is the opposite Aldebaran. So on, what's that, Saturday night, Vesta will be just a little bit to the right of that star.
Sorry, and the magnitude for Vesta, is it up on the screen?
It's not very bright, so you'd need binoculars to see it or a telescope.
Okay.
But you'll know where it is.
8.3. Okay.
By its location. Yeah.
Cool.
Okay, so we talked about, let's see about the Zodiac. So for the Zodiac, what we want to do is bring it back so we see lots of sky. The Zodiac are the constellations that the ecliptic runs through. So I'll just bring the ecliptic into view here. And I'm just going to hide away the obstacles on the landscape. And I'll just go back to our friend, the zero horizon. And I just want to also make the horizon a bit brighter. See if I can make this a little bit brighter. Okay. And let's put some boundaries on here so we can see. All right, so at 9 o'clock, yeah, here we go. So the first one would be Aries, Taurus, that's 2, Gemini, that's 3, Cancer the crab, that's 4, Leo the lion, that's 5, Virgo the maiden, that's 6, and that's all we get. Half of them.
Yeah, half. Plus Ophiuchus, but that's neither here nor there.
Not above the horizon here.
Not above the horizon.
No, yeah. Yeah, it's not half if you count Ophiuchus. Randy Atwood and I are both Ophiuchans.
Technically, let me adjust my glasses. Okay, the next question is, what time is solar noon where you live? And for this, let's say, what do you think? First person to tell us where you live in the comments. Let's choose solar noon where you live, shall we? Somebody tell us where you're from. Calgary. What's solar noon in Calgary?
Calgary. All right, so solar noon is defined as the time when the sun is transiting. Back to that term again. So in Calgary, Alberta, and I'll just get rid of some of the clutter on here. The sun is transiting around noon. So if I set this to 12 o'clock, you can see that the sun is not sitting above the southern horizon. So we have that issue. And most of that is cured by enabling daylight savings time. So if we spring the clock forward by an hour.
Could you repeat the last thing you said? Your microphone cut out. It was only about.
Sorry about that. I said the sun is not over the horizon, the southern horizon at 12 noon, because in the summertime, we put our clocks forward an hour and set daylight savings time in effect.
Okay.
So now I've got the sun closer to the southern horizon, but not quite. And the sun will be over the southern horizon at noon where you live, but what everybody in Canada and around the world does is we share the same time with everybody in our time zone. And that time zone is a span of from east to west. Everybody has decided to follow the same time of day. And so if you happen to live in the center of your time zone, then for you, solar noon happened on the hour. But in Calgary, solar noon happens at actually, where are we here? I got to pick the sun. Here we go. Transits at 1:38. So it's actually 38 minutes different from what used to be 12 noon, which is now 1 o'clock. So I've got to set this to 1:38. And that's when daylight saving, that's when the sun is transiting. So this is the local noon for Calgary.
Can you, sorry, your microphone's really cutting out quite a bit, but it's okay. I think we've got most of the idea. One thing from Colleen O'Hare, who's wonderful. Could you throw up the meridian just so we could get a visual representation too?
Yes, I can. Let's bring up the meridian. Might give it to us. Yeah, there we go. Yeah, so when an object is crossing the meridian, that's what we call transiting.
Perfect. Okay. Sounds good. I am seeing everybody's questions. We're going to save a lot of them for the end, just a heads up. Okay, next question. What boundary line did the sun cross over on March 19th, and what do we call that event?
All right, so the sun stays on the ecliptic all the time. It runs along the ecliptic, travels along the ecliptic by approximately 1 finger width per day, because it's 360 degrees to get all the way around, and it's 365 degrees in a year. So it's roughly 1 degree of travel every day. And the boundary that it crossed, I'll go back to my markings again, is the celestial equator. Let me draw the celestial equator on here. Here we go. So now if I aim south, you can see that the sun is currently, so the celestial equator is a big circle that encompasses the sky, and it divides the sky into a northern hemisphere and a southern hemisphere. And if you lived on the equator, the celestial equator would be straight over your head, anywhere along the equator. So we can see that the sun is right now sitting in the northern half of the sky. And if I wind this back to March 19th, you can see what's happening as the sun is dropping down. And so on March 19th, the sun crossed. Sun journeying along the ecliptic stepped over the celestial equator. Let me just go back and jump to the next day. So the day before it's below, and the day above it's after. So that's the moment that spring begins, when the sun steps over the celestial equator, enters the northern hemisphere sky, and our spring begins in the northern hemisphere. Fall begins in the southern hemisphere.
So essentially it's the middle point between its northernmost point and its southernmost point. Yeah?
Yes, basically, yeah. It's the turn of the seasons. So that's the first day of spring. When it steps back the other way, that's the first day of autumn.
Perfect, yeah.
12 months later, 6 months later.
There you go. I have a question that just came up from Doug Hardy, which I honestly have no idea how to answer. I'm not sure, Chris, if you'll know how to answer this. Using a sextant, you would call noon at the point when the sun is highest. Is that the same as we just described? No, right?
When the sun is transiting, it's at its highest.
And that's solar noon, but not actual noon.
It's so in the days before time zones were invented, every town used their solar noon, which is when the sun was highest for them. And they would set up their sundials, and their sundials would tell the correct time where they live.
Okay. So if you had a sun,
yeah.
Let's say you're in Toronto and you have a relative in Thunder Bay and you both have sundials set up, even though you're in the same time zone, they'll read different times because they're at different parts of the
Correct.
Cool. Okay.
Correct. And you'll be a few minutes, before the hour if you live east or west, and the reverse if you live west or east of the center line of the meridian of the time zone.
Okay. We are almost done the questions. We have 3 more. Oh no, lies. We only have 2. Which star in Gemini rises first, Castor or Pollux?
Okay, so let's turn off the equator here. We don't need that. So for that, we need to go into tonight's sky. Go back to today, go back to now, look into the sky tonight. So here's Castor and Pollux in Gemini. And this comes back to this idea of sky coordinates. So every spot, every star, every object in the sky has a coordinate. It can be north of the celestial equator, as I talked about before, and it can be east or west or east of each other. And so if I were to run myself equatorially and put up my equatorial grid, then you can see that north is up and west is to the right and east is to the left in this grid. And you can see that Castor is actually west because it's to the right of Pollux, and Castor is also north of Pollux. And if I put Castor in the middle of the picture and I wind the time back, again, I'll just put the equatorial, turn the equatorial mode off here. We can see that both of those stars rise during the daytime, around the middle of the day at this time of year. What I'll do is I'll just jump back about an hour. So we can see that Castor rises at 10:31 in the morning, and Pollux follows it.
Okay. This is
so objects that are west rise first, objects that are east rise second.
This is one of these things that you absolutely do not learn in school a lot of the time, is spatial awareness and spatial sort of figuring out how orbits work and when to see things and all that sort of stuff. So this is a good step in that direction for figuring that out.
Yeah.
And we come to our last question before we dive into questions from other folks. How many degrees of the sky does Orion's belt span?
Okay, so let's get into the nighttime sky. I'll just turn off this equatorial grid and wind us back to see Orion. So to answer this question, in Stellarium, you would need to use the angle measuring tool, or you could click on one star, read off its coordinate, click on another star, read off its coordinate, and take the difference between the two. Or you could head outside and you could point your finger up, put a finger up, and you could see at arm's length how many fingers would fit between the stars of Orion's belt. And so if you did that, you'd find that approximately one finger would fit here and another finger would fit here. So it's about 2 finger widths across. And if I actually measure it, I'll just zoom in to get a nice accurate measurement. I click on one star, drag over to the other star, and I get 2 degrees, 43 minutes, and 43 seconds, arc seconds of sky. So that's approximately 2 finger widths, a little bit, maybe a bit more than 2 finger widths across.
Okie dokie. That's a good one to go out and try on your own, because Orion's belt's pretty easy to find, and we're not going to have it up for too much more longer, eh?
That's right.
Alrighty, well, that covers all those questions there. Thank you all for doing that homework and having it as our guide. Don York has been answering every question in the chat, and I'm very impressed. He's just sending them to us, but I guarantee you that he's doing very well.
Cool.
Chris, do you want to answer questions, or do you want to focus more on constellations right now?
I think we should answer questions because people are here and they've asked them. So let's do that.
For sure. Okay. We have lots of questions. We can get through a lot of these really quickly. Can you discuss, I love SI units, Sistema Internacional, metric units. Can you discuss standard candles? Standard
candles. Okay, so here's that issue we talked about earlier where I don't have pre-research done.
I don't actually know much.
But I can tell you the basic concept, the basic idea. And Orion is a good example of doing that. So the brightness of a star that we see in the nighttime sky is controlled by a couple of different factors mainly. One is how close it is. So if a star is very close to the Earth and to our solar system, it tends to look brighter in the sky than the stars that are much farther away. If that makes sense. But the other twist on that, and that wasn't always known until, until more recent times, the last couple of centuries, is that the stars themselves can be inherently different luminosities, different brightnesses. So you could have two stars that look the same brightness in the sky, but one could be much brighter than the other one, but farther away. And so that increased distance away balances out that extra brightness and makes them look the same brightness. So normally the star Betelgeuse and the star Rigel are about the same brightness in the sky. Now Betelgeuse hasn't been as bright lately because we went through that period of dimming late last year, and it's still recovering back up to its normal brightness. I think Dr. Percy of U of T is planning to give an online session talk about Betelgeuse in the coming days. Yeah.
Ooh, okay, I'll see if I can find.
He's actually an expert. So Betelgeuse is a variable star, which means its brightness varies over time, and he will explain why he thinks the reason it dimmed was a combination of a rare synchronization of a bunch of factors that produce the dimness in the star. So he'll talk about that. So Betelgeuse is at a distance of about 500 light years from our solar system, and it shines with a magnitude of 0.45 brightnesses. We can talk about what magnitude numbers mean in more detail in a future session. And Rigel, it's nearly twice as far away. It's 862 light years away, but it has a similar range of brightness. And so Rigel is more luminous. Now, what astronomers like to do is talk about the absolute magnitude or the standard. Well, let's talk about absolute magnitude first. So if you were to sit the same distance from any particular star and look how bright it looked, then you could determine its actual luminosity difference compared to another star, right? Because if you're 10 light years away from Betelgeuse, it'll shine X brightness. If you're 10 light years away from Rigel, it'll seem twice as bright or something like that. And you could pick any star and sit at that given distance and measure its brightness. So we call that absolute magnitude versus apparent or visual magnitude. And what standard candle refers to is the fact that there are objects in the universe that shine with a known brightness, and that if we see them looking dimmer than we expect, we know they're farther away. And if we see them brighter than we expect, we know they're closer. And so we can actually use those kind of tricks to determine the distances to other galaxies and other other objects in our universe. So early astronomers would study stars that were of known brightness, or events that happen that are of known brightness. You can have supernovas that always shine with a given certain brightness because of the physics involved in making them. And if we see them look brighter or dimmer, we know they're either closer or farther. So it kind of separates out those two phenomena of nearness and brightness. I think that's a little high-level overview of it, but
Okay.
I hope that's relatively clear.
And see here, I was just gonna, I wouldn't say make fun of the Americans, but these like barrel and candle and like units for things that are based on other things. I don't know. I've never been a big fan of them.
Well, a lot of our physics, you know, still uses nomenclature that was coined pre-industrial. So
For sure. Yeah. It's, what are you gonna do?
they didn't have a 60-watt light bulb to be standard.
That's fair. There's a couple of sort of technical-ish questions about Stellarium. Do you want to ask those, or do you want to answer those? I don't see Blake in the comments this time, so I don't
Sure,
think Blake's
sure, I'll try.
answering the technical
Yep.
stuff. So things like, and these can be quick, can you find quasars in Stellarium?
You need to know the designation to type in. So I'm not sure if you can just say quasar. Let me just see. Lists. Let me see what's under lists. Don't think that's a choice. Might be one for quasars. Yeah, possible quasars is in the list. So you could do this and you could pick one and plot its location on the sky that way.
Perfect. Okay, cool. Excellent. Thank you. There's another question. I'm not sure how to do this. How do you get the Hubble telescope photos of galaxies to show in Stellarium? Donna only sees a dashed ellipse.
So go down here and look for the icon of the spiral galaxy and make sure that's turned on.
Oh, okay.
So if I were to say, take Messier 106 and zoom in on it, then I get both the symbol and the Hubble scope. If I turn off that, that's the symbol control. This is the photo control.
Okay, perfect.
There
Okay.
it is there. Sorry.
Excellent. Thank you. And then there were some questions about traveling to the moon, the sun to view things. How do you do that again?
So what you do is you go to the, you need to go to the, this is F4, which is the sky and viewing options option. And then you tab along till you find landscape. And then if you look at landscape, and let's just bring this back, and set it up to different landscapes. Okay, so that'll just change. That's not changing where I'm viewing the sky from. It's just changing the photo that's around it. But if I want it, and I can even make the Calgary have Mars as horizon if I want to. All right. But if I actually want to go to Mars, then before I do that, I need to click on this option, use the associated planet and position. So I need to turn that on and then click Mars. And then I'm on Mars.
Okay.
Okay. Or the moon. So I'm seeing the sky from those locations, or Saturn or the sun.
Perfect.
That's how you do it.
Excellent. Okay. And then there was a couple, this is sort of moving, let me just check, moving away from constellations a bit, and moving into some more like high level questions and also news questions, because Comet Atlas, which we've talked about almost every single session, has let me down. I don't know about everybody else, but can you
know
update
what?
us?
Astronomers like me, we knew not to get our heart and set our hearts on it.
I'm a young astronomer. I'm not ready.
Let me show you a cool page that a number of us use. So this is a page run by a gentleman named, what's his name? I forget his name. It's in here. Seiichi Yoshida, and he makes it a point of tracking comets and what they're up to. And if you go to his page, which is called arith.net, and scroll down a little bit, you can see he's got weekly information about bright comets. So go here, and he talks about the comets that are currently in view. And he has a little summary. It's not always, current as of today, but I think he updates us every few days or every week. And if you click on one of these comets, so this is Comet Atlas that we're all kind of semi-mourning right now. Click on the comet, and it'll show you a little bit about the discovery date and its orbital elements and where it's going to go in the sky. But this is what I wanted to show you. This is a plot of its brightness versus date. And once the comet appears and we start understanding its orbit, we can predict roughly what we expect it to do in terms of brightness. And it generally will go brighter when it's closer to the sun and also closer to the Earth. So it's closer to us, so it's a little brighter, but it's also maximum warmth, and so emitting the maximum gas when it's at so-called perihelion or closest to the sun. So Comet Atlas perihelion is due to happen in about June. And so that was the predicted peak of its brightness. And you can see that the number here is 0. That number 0 would be as bright as the star Vega, which is the brightest star in the summer sky. So everybody got really excited and thought, oh, this comet's going to be naked eye, and we're all excited. But you can see here, these are the observations that people have submitted, their estimates of its brightness. And I don't know if you can tell from this picture, but there's a little hook downwards right here that's happening. So it's a couple of, this is sort of a scatter of observations. There's still hope, but there's this hook downwards that maybe is it fizzling. So we have to stay tuned. We have to stay tuned and see what happens.
Some people are suggesting that it might be breaking up.
Yeah.
There was and I've said this before, but I'm going to say it again because it's my favorite comet related quote from David Levy, which was, comets are like cats. They have tails and they do precisely what they want to. It's really hard for us to predict what's going to happen. So, you know, we don't know what the comet's made of. It might break up. Yeah. And that might be what happened.
I just want to mention something about binoculars and telescopes too. So this magnitude number around 878, this is certainly binoculars range. I tried seeing this comet with my big telescope a week or two ago, and I had trouble from where I live in Thornhill. So from the urban environment, it just was much too diffuse for me to pick it up. But a lot of rascals are nice photos of it. And, you know, you'll cover it in your astrophotography session. I'm sure next week you'll want to talk about comets.
Yeah, I'll ask Paul to talk about comets.
All right. Any more questions?
We do have a few more, which was, there's one, this is a math one. So I took a second to try to think through the answer and I didn't quite get it right. If the galaxy and the Leo triplets were to move away since the light has reached us, and has been traveling for 45 million years, will it appear to stay in the same place from before it moved away? And my answer, I think, having thought through this a little bit, would be it would appear to be moving away faster than if it were, because if it were moving towards us, the light would be catching up with itself a little bit. But if it's moving further away. So
yeah, galaxies, in general, the universe is expanding, so the galaxies are all redshifted from our point of view. But the galaxies that are in our local group that are gravitationally bound to our Milky Way, that like the Andromeda galaxy, will still be approaching each other because their gravity is pulling each other together. I don't happen to recall off the top of my head whether the Leo triplet galaxies are approaching or receding from us. I think that information might have been stated in the max information I showed, but I don't recall. Let's go back a couple hours here. So let's see what it says. I'd have to show all the information. So the universe expansion is slow compared to the 45 or 60 million light year distance that these galaxies would be. So I don't know that you'd see much of a difference.
Yeah. So I mean, if you wanted to think of it in a hypothetical world where that galaxy could move at light speed, then it would make a difference. But the galaxy is moving at a fraction of the speed of light, so it really wouldn't make too much difference, other than the galaxy would look a little red, because the light is.
Here's the redshift. It's got a positive redshift, which means it's receding from us.
That's sort of like, if anyone knows the Doppler effect, when you hear, like an ambulance, or if someone's in a car playing a tuba, which I don't think happens that often, but if they were and it's driving really quickly towards you, and the pitch kind of goes as it drives by. It's because the sound waves stack up at the beginning, and it makes the sound more compressed and higher. And then as it's traveling along, after it's gone past, the sound waves spread out because they're moving away, and the pitch gets lower. It's like that, but with light. So if it's moving
so it's
towards
the wavelength, actual wavelength of the light, the distance between the peaks of energy gets stretched or squeezed, and that changes the color of the light.
Which is why the stuff moving away.
So light becomes redder when it's being stretched, and it becomes bluer when it's being compressed.
Yeah, so that's how it would look different. And I think that more or less, there's one last question, but actually, I'll get to. So there was a question about iPhone apps and an app that could turn your whole phone red, not just when you were using it, but like have a night version for your whole phone. If you don't know enough, do you have one of those off the top of your head, Chris?
As far as I'm aware, and this may be, this constantly changes as phones get updated and so on, the Apple phones have a red screen option, which lets you turn them quite red. The Android phone, I have the Samsung phone, and it will filter the blue light. So it'll go warmer color, but not enough for astronomy. Most astronomy apps will have a red light mode. So for example, I could just bring up Sky Safari here and show you on my screen. Let's see, can you see Sky Safari?
I think that's background.
Too bad. Anyway, it has a mode where you can, one tap will turn the whole thing red, but that will not stop texts and phone calls from bringing up bright notifications. So what I always do is I bought some self-adhesive red film that'll just peel off, and then I'll reuse it. I'll peel it back on.
Good idea.
And
then
fit the shape.
One last big question. We're going to wrap up with this one because it's an hour in now. This was from Babak, and we had the question that you remember back when you showed us that all the planets were together in November of the year 1 AD. First of all, what was the actual date for that?
I think it was November 11th of the year 1. Let's just see, 1, 11. Something like the 11th. Let's try this. And it was in the morning. So let's try 5 in the morning. Turn off these. That'll be in the eastern sky. Here we go.
Oh, there we go. Okay.
I'm just sort of going by memory here. I guess it would have been, here we go.
There it is. Oh, yeah. Wow.
Yeah.
November 6th and 7th. Okay. So the question was, when will that ever happen again? Which I don't think you would know off the top of your head. You could theoretically go through Stellarium and watch.
Yes. And you can Google a term like that. So you could Google, when is the next, say, Jupiter and Venus close conjunction? And there have been websites, and there are computer programs that can actually calculate those encounters. So they do all, they do the mathematics, and they're able to predict in the far future and calculate those things.
Okay.
But I know off the top of my head.
Off the top of my head either. I do want to mention that if you're a member of the RESC, you already get Sky News. Sky News in the January-February issue, the first one of the year, outlines all the interesting conjunctions that are happening for the rest of the year. If you're looking for like a nice big overview, the exciting conjunction this year, which is going to happen pretty much right at, I think, sunset or sunrise. So it won't be great to see, but that's December 20th. And that's when Jupiter and Saturn are going to be so close to each other that if you have a telescope, they'll be in the same view, the same field of view, and you'll be able to see the rings on Saturn and the stripes on Jupiter through one telescope, which is so cool. It won't happen. It's going to take years and years and years for that to happen again. I can't remember how long, but it's very exciting. It's going to be very difficult to see. If you don't have a telescope, it'll just look like a bright double star. It'll just look like two stars really close together. But that's the big exciting one this year.
Yeah, so all year long, and we'll get into that when we get into our summer stargazing season, Jupiter and Saturn are going to sort of chase each other across the sky all year long. So we can get into that in a future session.
Yes. Okay, I think that wraps up all our questions for now. Answer that left on. Thanks everybody for joining. There's a couple people. Oh, I'm going to just copy and paste Some answers from folks in the chat about a red screen for your iPhone. There's that. Perfect. Thanks, everybody. Oh, is that what it's going to look like, Chris?
No, what's going to look like is underneath there. There's what it looks like, Saturn and Jupiter. No, what I was going to do is if anybody wants some observing ideas for the next little while with this, when the sky is clear, I posted a post on my AstroGeo Skylights page of some observing suggestions for mid-April, and I've given you some really cool double stars that are pretty easy to see. And this is a close-up view of the star Castor through a telescope. And you can use Stellarium to preview what you're going to look at by centering the star and zooming in on it. But just remember that your telescope might flip the view around, upside down or left and right. So the arrangement that you see in your telescope may be different from Stellarium. And if you go to this page, I'll put some highlights on here so you'll know which of these stars to look for. So you can chase that down on your spare time. And if you want to match your telescope using Stellarium, you can use these flip buttons. And the best way to do that is to take your telescope out when you see the moon, compare how the moon looks, then look at it through your telescope and see what the telescope's doing to the moon. Is it flipping it upside down or mirroring it or both? And make a note, because your telescope will always do the same thing to every object.
Okay, good to know. As we're wrapping up, I am going to mention one last thing. Next week, Chris is taking a minor hiatus. We're taking a tiny break from doing Stellarium, and we're going to focus on astrophotography. So the first session next week on Tuesday is going to be an astrophotography for beginners using iPhones and DSLRs, stuff that you already have. And then that's going to be delivered by Paul Owen, who's a volunteer out in New Brunswick. And then the next session on Thursday is going to be about introductory Photoshop. And that's going to be delivered by David Schumann, who is a volunteer in Montreal. And to kick that off and get you all feeling inspired, we've got a contest running this weekend. So between now and Tuesday morning, head outside and take a photo of something in space. And when I say in space, I mean above, at low Earth orbit or above. So that could be satellites, that could be the ISS, it could be the moon, it could be Venus, because Venus is up right now. It could be the stars if you're feeling ambitious. So head out, take a photo. Doesn't have to be good, just give it a try. And then post it on either Instagram or Twitter and tag Chris, who is at AstroGeoGuy. I'll add that down. Tag Chris and then tag the Royal Astronomical Society, Royal Astronomical Society Canada on Insta or Rask on Twitter. So tag both of us and then use the hashtag astronomy time. And if you do that by Tuesday at 10 a.m., that's the deadline, and we're going to choose a winner and announce it Tuesday at 3:30 p.m. I'll post that on social media as well, and we hope to see your photos.
Yeah.
Perfect. Oh, and I forgot to mention, there's a prize. Haha, duh. The prize is we're going to send out a copy of this issue of Sky News for you, and Night Watch, which is one of my favorite books for introductory astronomy. It's got so much information in there, and it's got essentially hard copies of all of the stuff that's in Stellarium right now, which is fantastic.
And it's Canadian, right?
And it's Canadian. Yeah, Canada. So we're going to send those out, participate in that competition. I'll send out the extra details on social media, and we will see you all next week.
Thanks, everybody.
Thanks, everyone, for joining. Thank you, Chris, for telling us all about the sky again.
You're welcome.
And we'll see you in a week this time for you, and everybody else will see you on Tuesday.
Yeah, keep looking up.
Keep looking up, guys. Take care.